The final dimension of the wave, which we're going to discuss, is the wavelength. So we've spoken about frequency, which is the rate at which the sinusoid repeats itself, measured in hertz, determined by the characteristics of the sound source, and the speed of sound, the rate at which the disturbance is propagated through the medium, measured in meters per second, determined by the elasticity and the density of the medium. The wavelength shows the relationship between the frequency and the speed of sound. So the wavelength is the distance traveled by a sine wave during one period of vibration. It's directly proportional to the speed of sound and inversely proportional to the frequency. The wavelength relates to the frequency and the speed of sound. It's the distance traveled in one period. Wavelength equals speed of sound divided by frequency. It is proportional to the speed of sound, and it's inversely proportional to the frequency. Looking at this figure, we have two waves, a wave with a frequency of 1100 Hz and a wave with a frequency of 550 Hz. There are two different mediums, the medium of air and the medium of water. First, let's compare the frequencies of the waves. The wavelength for the frequency wave of 1100 Hz is 0.3 meters. The wavelength for the frequency of the wave at 550 Hz is 0.6 meters. So there's a longer wavelength for the lower frequency sound. Now let's compare mediums left to right. In the example of the 1100 Hz wave, in air, its wavelength is 0.3 meters. In the medium water, its wavelength is 1.2 meters. The wavelength is also longer in the medium of water for the frequency wave at 550 Hz. In air, this wave has a wavelength of 0.6 meters. In water, it has a wavelength of 0.24 meters. And how are these calculated? By using the formula. Wavelength equals the speed over the frequency. The period of vocal fold wave during vowel production by an adult male is only about 10 millimeters per second, and a female is just over 4 meters per second. Our wavelengths in air are relatively large, 5 feet for a female and 11 feet for the male. So the male has a longer wavelength because men tend to have lower frequency voices. So lower frequencies travel farther than higher frequencies. That's why men are easier to hear than women. The speed of sound is governed by the properties of the medium. The frequency of vibration is governed by the properties of the source. Wavelength simply shows the relationship between the two quantities, the speed of sound and the frequency.